Welcome to Lesson 1, Classify Polygons. Our objectives in this lesson are to classify polygons by applying some different formulas that you have already used, like the distance, midpoint, and slope formulas. Down below here, I've listed these for you to put down in your notes in case you can't find them, or you've misplaced them, or you just want them to be current with this lesson. We have three formulas. We have the distance formula, the midpoint formula, and the slope formula. Remember that the distance formula is really just a form of Pythagorean theorem, and it's used to find the length of the sides. So when do we use it? When we're trying to determine if sides are congruent. That's how we'll use it in this lesson. The midpoint formula is just the average of the x-coordinate and the average of the y-coordinate. It finds the middle of the line. And so we will use it to determine the coordinates of the midpoints of the sides. And finally, the slope formula, remember, is just how steep a line is. It's rise over run, so it's the change in y over the change in x. And when do we use this? We use this to determine if opposite sides are parallel or perpendicular, but for this lesson we are going to look at whether opposite sides are parallel. Let's go ahead and look at our first example. In this example, we want to determine whether this triangle ABC is scalene, isosceles, or equilateral. Well, how do we do that? The first thing is to remember what scalene, isosceles, and equilateral mean. Scalene means that each side has to be different. There can be no sides that are congruent, so all three sides need to have different lengths. Isosceles means that we have two sides that are congruent, or two sides that have exactly the same lengths. And finally, equilateral. Equilateral means that all three sides are exactly the same length, so they would have to have the same measurement. Well, how do we find the lengths of the sides? Well, remember our three formulas that we're going to be using. The distance formula helps us to determine whether sides are congruent by finding the distance, the length of the side. So we're going to use the distance formula for this. In order to use the distance formula, we do need to have the current coordinates for each of these points A, B, and C. So let's go ahead and write those coordinates now. First we have A, and that's at 0, 1. We have B at 4, 4, and we have C at 7, 0. Now we can use these coordinates and apply that to the distance formula. So we need to find the distance of side AC down here. We also need to find the distance of side AB, and we need to find the distance of side BC. That will be our last one. So let's go ahead and start with side AC. Remember that the distance formula is the square root of the change in our x-coordinate squared plus the change in our y-coordinate squared. So if I look at AC, if I look at my x-coordinates, I have 7 and a 0. Order doesn't matter because I'm going to square everything, so I should not get a negative. Now for my y-coordinates, I have a 0 and a 1. So I'm taking the difference and I'm squaring it. When I simplify this, 7 minus 0 is 7, and 7 squared is 49, plus the difference of my y-coordinates, 0 minus 1 is negative 1, and negative 1 squared is going to be positive 1. This is equal to the square root of 50, which I could put in my calculator, but the square root of 50 will tell us enough if we compare that to the other sides. So this side length is the square root of 50. Now let's look at side AB. So we're going to take the square root of the difference in my x-coordinates, and I have a 4 and a 0, so I'm going to take 4 minus 0 and square it, plus the difference of my y-coordinates, which is a 4 and a 1, so I'm going to take 4 minus 1 and square that. When I simplify this, 4 minus 0 is just 4, and 4 squared is 16. 4 minus 1 is 3, 3 squared is 9. I get the square root of 25, which I can simplify that to be 5. Okay, I now have two sides, so I can start eliminating some of these triangle options. Since these sides are both different, I know that I can't have an equilateral triangle because an equilateral triangle says that all sides have to be the same. I could have a scalene, or I could still have an isosceles if this side was 5 or root 50. So I need to keep calculating. Let's do our last side. side BC. If I take the difference of my x-coordinates, I get 7 minus 4 squared plus the difference of my y-coordinates, which is going to be 0 minus 4 squared. When I simplify that, 7 minus 4 is 3, 3 squared is 9. 0 minus 4 is negative 4, but negative 4 is positive 16, which simplifies to the square root of 25, which I know is 5. Okay, now I can see that I have two sides that are the same and one that's different. So I don't have a scalene triangle. What I do have is an isosceles triangle. Let's look at some quadrilaterals. In order for you to be able to classify quadrilaterals as a rectangle, square, rhombus, or parallelogram, you need to know some of the important characteristics. Well, let's go ahead and skip trapezoids because we're not looking at those today, but let's look at a parallelogram. All of these shapes fall under the umbrella of a parallelogram. A parallelogram has two pairs of parallel sides, meaning this top side is parallel to the bottom, and the one on the left, the vertical side, is parallel to the one on the right. As long as you have a shape that has two pairs of parallel sides, you can safely say it's a parallelogram. A rhombus is a parallelogram, but all the sides are congruent. So, and these should look like this, by the way. I was making congruency marks rather than parallel marks. With a rhombus, all the sides are congruent. So each of these sides will have the same length, the same distance. With a rectangle, we have a parallelogram, so we know that opposite sides have to be parallel, but notice that all four sides are not the same length. With a square, all four sides are again the same length, and opposite sides are parallel. So this is the start to helping you to classify a quadrilateral. So make sure you keep these in your notes as well. Let's try a quick example. Here we have a quadrilateral QRST, and we want to show that it's a parallelogram. Well, how do we show that it's a parallelogram? Well, remember the definition, opposite sides have to be parallel. And how do we know if sides are parallel? Well, down here we have our slope formula. This determines whether opposite sides are parallel. So we need to find the slope of each of our lines. So we need to show that QR is going to be parallel to side TS, and we also need to show that side QT is parallel to side RS. So we need to show that this side is parallel to this side, and this top horizontal side is parallel to this bottom horizontal side. Let's go ahead and start with QR. Remember, slope is rise over run, or change of y over change of x. So if I look at QR, I can take my y's, 3 minus 1, over my x's, 2 minus a negative 3. 3 minus 1 is 2, and 2 minus a negative 3, these both become positive, and we get 2/5. So the slope of QR is going to be 2/5. Let's check the slope of TS. If I do the change in y's, I can have negative 1 minus a negative 3 over change in x's, 3 minus a negative 2. Well, remember that we can change these to both be positive, and we get 2. 3 minus a negative becomes positive fifths again. So we have now shown that the top line and the bottom line are indeed parallel, but we're not done. We need to show then that the vertical lines on the left and right are also parallel. So we need to show that QT, which would be 1 minus a negative 3, and again, order doesn't matter as long as I'm consistent between the numerator and the denominator. And then we have negative 3 minus a negative 2. So here I get 4, and on the bottom I get negative 1 for a slope of negative 4. Always check to see that that makes sense. And this is a negative slope because it drops down from left to right. All right, finally, I just need to check RS. So if I do my change in y's, I'm going to do 3 minus a negative 1 over 2 minus 3. Well, 3 minus a negative 1 becomes positive, and I get 4. 2 minus 3 over negative or 2 minus 3 equals -1, which simplifies to -4. So both of these slopes are -4 as well, and I've now proven that QRST is in fact a parallelogram. I have two sets of parallel sides. Okay, let's look at one final example. In this example, we want to determine the type of quadrilateral that is made by connecting our midpoints. Okay, so how do I determine a midpoint? Well, I could guess and I could get it pretty close, but since these lines are not perfectly horizontal or vertical, I really need to calculate it. What formula would I use to calculate midpoint? Well, the midpoint formula. Okay, let's go ahead and do that then. So to find the midpoint of Ki, remember that I need to take the average of my coordinates. Well, if I look at my coordinates here, I have this coordinate should be at -4, 0, and this coordinate should be at 0, 4. So I'm just averaging my x's and averaging my y's to get a midpoint of -2, 2 right here. All right. Let's move on to IT. Here's IT. We know these coordinates. This coordinate here is going to be at 8, 0. So if I take the average of my x's, 8 plus 0 divided by 2, and 4 plus 0 divided by 2 right here, I get a coordinate of 4, 2, which would be my midpoint. Do that in orange. All right, let's move on to the midpoint of TE. Down here, E is at 0, -4. So again, finding the average of my x's, the average of my y's, I get 4, -2. Oh, that's the one I already did. Which one am I on here? Let's go ahead and look at EK. So if I take the average of my x's here, -4 plus 0, and 0 plus -4, divide each of those by 2, I get a midpoint of -2, -2. Oh, and it looks like IT right here, 4, 2 is the midpoint there. Okay, so I have calculated the midpoints on each of these line segments. Notice I have 4 calculations. I'm taking the average of my x's between each midpoint or between each endpoint, taking the average of my y's. Okay, now I have my midpoints. What do I need to do next? Step 2 says draw a diagram of ABCD. So if I draw this, I can label this now A, B, C, and D. I have drawn a diagram. You can see by this diagram, though, that it's going to be easy to determine what type of quadrilateral this is because all the lines are either horizontal or vertical. We can see that the top two are parallel. The vertical ones are also parallel. The vertical ones, because they are both vertical, are also congruent, and the top two, because they are both horizontal, are also congruent. So, since line segment AB and CD are both horizontal, and BC and DA are both vertical, we know that they form right angles, and we can tell that this is then a rectangle. It's a parallelogram, but specifically a rectangle. And that concludes our lesson on classifying polygons. So just make sure that when you are doing the practice or doing your assignments, that you show your work like this in order to prove what you determine, whether the quadrilateral is a rectangle or a rhombus, or whether a triangle is isosceles, scalene, or equilateral.